SwayamPrabha. Digital India. Educated India.
Hello everyone. Now we will start a new module which is extreme cold protective textiles and ergonomics. So, special textiles are required to protect human from extreme cold condition. So, in this module what we are trying to learn that the introduction the objective of this module are the understanding the human physiological response is important to in the particularly in extreme cold environment. We want to analyze the textile technologies and materials for cold protection, that is very important, and then we will try to apply the ergonomic principle in cold weather clothing, and comprehend the international testing standard and protocols. We will try to understand especially for extreme cold weather clothing, and the applications like military, industrial application and recreational sector in the sports. So, different sectors we will try to see how the extreme in extreme cold condition the textiles are used for protection. Now, what is extreme cold environment? Let us try to understand. So, any environment with air temperature less than 5 degree Celsius, we can call it as extreme cold environment. So, less than 5 degree Celsius if we reach. So, key factors of cold environments are obviously first is the air temperature. So, air temperature is primarily determinant of cold stress. So, at if the air temperature reduces, that means body heat or body heat will be released very quickly at a higher rate. Wind speed which accelerates the heat loss from the body. So, wind speed is another environmental factor, and it is basically we lose heat through convection. So, the air will take the body heat from our body. Humidity level also affects. So, it affects the provided temperature and comfort. Duration of exposure is also important. So, if someone is exposed for short time at a particular temperature, that may not be that much serious than a person like a military defense person. So, they are working, they are staying there for long hours. So, in that case the protective gear must be there. So, what is the definition of extreme cold environment? We are now trying to define. So, key environmental factor as we have discussed the air temperature. So, air temperature is the primary factor. So, air temperature controls the body heat loss by conduction, convection and radiation. So, due to the temperature difference, our body heat is actually comes out to the environment, and as the temperature gradient is more at lower and lower temperature, the body heat loss rate of body heat loss will be higher, and the radiative heat loss will be maximum because of the fact that the quantity that of radiative heat loss, it depends on the fourth order or fourth power of the temperature as per Stephen Boltzmann's law that we will discuss. So, below 10 degree the dexterity drops, and below 0 degree Celsius shivering starts. So, our body movement, hand movement and all this thing we actually try to with the free movement will be lost below 10 degree. We do not want to move, okay, but at below 0 degree Celsius shivering starts. Clothing should keep the skin microclimate near 33 degree Celsius. So, what we have seen that 32 plus minus 1 degree Celsius is the ideal microclimate temperature. So, our microclimate temperature should remain around 33 degree Celsius irrespective of the fact the environmental air temperature. So, that is how the insulation should be there. Now, coming to the wind speed, it's in extreme cold condition, wind greatly intensify the convective heat loss and speeding body cooling. So, when in extreme cold condition the wind starts blowing, it will take our body heat through convection, okay, and body cools down very quickly. So, in that case we should stop the wind to come in contact with our body. We should wear certain clothing outer layer, so that it protects our body heat, it prevents the body heat to get released through convection. Wind lowers the perceived temperature. So, that is called wind chill effect. So, at certain temperature, suppose the temperature is at minus 5 degrees Celsius, and if in case of wind, if wind starts blowing, that this temperature, that the perceived temperature, that we feel like temperature will be typically 10 to 15 degree lower. So, we may feel say maybe minus 15 degree Celsius or to minus 20 degree Celsius. So, even we are at minus 5 degree Celsius the air temperature, but if we start the wind starts, so then it will be very chilled. So, that is called wind chilled effect because of the very quick heat release due to convection. At minus 20 degree Celsius with 20 kilometer per hour wind speed, perceived temperature will be dropped by 15 degree Celsius, that is minus the person can feel the temperature like minus 35 degree Celsius. So, that is called wind chilled effect. So, when the wind blows, so in that case we should have we should protect ourselves in different way. So, wind penetration reduces the insulation efficiency of the clothing layer. In addition to the convective heat loss, so if wind penetrates, so that will have the reduce the insulation efficiency, because it will take the heat through the convection. So, in those cases windproof outer shell is there. We should use the windproof outer shell to prevent ourselves from frostbite and maintain the core temperature. So, that is very important here. Okay. So, in case of wind, when there is a chances of wind, so in most of the extreme cold climate clothing, we use the outer shell, windproof outer shell. Then comes the another environmental condition, environmental factor, which is humidity. Okay. So, warm summer day and cold winter day, where the humidity may be more than 80% humidity. So, that is the in extreme cold condition at low humidity, say less than 30% caused skin and airy dryness. So, which increases the discomfort and heat loss. But at high humidity more than 70% at sub-zero temperature, which enhance the conductive cooling, air at minus 10 degrees Celsius at 80% relative humidity. If the relative humidity is very high, in that case the person will feel like minus 15 degrees Celsius, because the dry layer inside the dry space inside the clothing is being replaced by the moisture vapor, and which enhance the conductive heat loss. So, that is why people will feel like the more cooling, so minus 10 degree Celsius will feel like minus 15 degree Celsius. Typically, it should be the humidity at humidity say around 50% humidity, that this conductive cooling will be lower. Now, the moisture in clothing can reduce the insulation, that is well known. So, that is what we have discussed. So, inside the clothing, if moisture is there, that will enhance the thermal conductivity, and insulation may be reduced to 30 to 50%, and which accelerate the body cooling by conductive heat loss. Maintaining 40 to 60% humidity, okay, in microclimate helps passive warming and comfort in cold exposure. So, typically around 50%, if we keep the moisture vapor in the microclimate, that will keep our body warm. So, extreme there are different types of extreme cold environment. So, Arctic operations that takes place between minus 40 degree Celsius to minus 70 degree Celsius. High altitude mountaineering is also there, where the temperatures are variable with altitude. Okay. Industrial cold storage. So, people used to work in the industrial cold storage, where the temperature typically around from minus 18 to minus 30 degree Celsius. The person working inside the cold storage should be protected, and polar expedition, so sustain sub-zero condition. So, these are different wind cold environmental condition. So, see the in extreme cold condition, the body core temperature, outer layer is extreme cold and our body is exposed to the extreme cold environment, and here the body core temperature drops gradually by quick release of heat. The rate at which we produce it is much lower than the rate of release of heat due to the temperature gradient. So, in extreme cold environment, our body continues liberation of heat from the body. So, where heat loss, rate of heat loss is more than the rate of heat production. So, our body heat produce due to metabolism. So, that heat production due to metabolism, there it has got some limit, but the heat loss is basically a function of the temperature drop, temperature difference. So, in that case, if the heat loss is more than heat production, in that case our body core temperature will steadily start dropping and we will face the situation which is called hypothermia. So, hypothermia situation will occur. In that case, now and thermal distress, what are this condition? So, different type of conditions will happen depending on the drop in body core temperature. As we release the body core heat, so at core temperature it should, when it should be typically around 36 to 37 degree Celsius. So, if it is becoming 34 to 35 degrees Celsius, the person become confused and shivering stops. Shivering will be there when the body core temperature is close to 35 or 36 degrees Celsius there, but shivering will start stopping. It will stop at about 30 degree core temperature. We are talking about the core temperature of the body, not the skin temperature. So, body core temperature has dropped from 37 to say 30 degrees Celsius, the person become unconscious. So, this unconsciousness can be brought back, that is maybe he has become conscious if we rewarm it, or so the heart will stop beating at about 27 degrees Celsius core temperature. So, at if the body core temperature becomes 27 degrees Celsius, so that we cannot survive. So, that is the situation. So, we should not reach this situation, we should try to keep our body core temperature at the normal 36 degree to 37 degrees Celsius. So, threat from extreme cold is very high. However, the person can be brought to consciousness by proper rewarming if he is becoming unconscious, even very low core temperature. So, at if the core temperature becomes 30 degrees Celsius, if he is unconscious, so by proper rewarming, reheating, so that he can be brought to the consciousness. So, what are the effects of unusual climate? So, effects of exposure of cold if sufficient clothing is not worn. So, in this case vasoconstriction of blood vessels takes place. So, vasoconstriction is that the physiological phenomena where the blood vessel will get constricted, the diameter reduces and it reduces the blood flow to retain the body heat. Muscle tone with the tensioning of muscles will start, that is it will it is the onset of the shivering, and the shivering starts of the muscle with increased body heat production. So, that is it will try by muscle shivering tone that it will try to body physiology will try to enhance the body heat production, and in that case human body needs well designed multi-layered protective clothing to overcome all these problems. So, in this situation we should have properly designed extreme cold protective clothing. So, let us try to understand the evolution, how the this different types of clothing has evolved starting from animal skin to smart textiles. So, this evolution if we know, so then if we understand this evolution, then we can go for the future development. So, at a very old day like prehistoric era, so animal fur or natural materials are used which provides the basic insulation and protection. So, animal furs are widely used for protection, and early 90s people used to use the wool and cotton based layer, a different layer system for polar exploration. So, that in early 90s we used to use this type of clothing. In 1940s to 1960s, in that case when the synthetic fibers have invented, they are developed. So, then people started using the synthetic material with improved manufacturing techniques. Then 70s to 90s, then technical textile emerges and membrane technology was introduced, and that improves the protective performance of clothing. And in the last 2.5 decades, the smart textiles, nanotechnology, phase change materials are incorporated within the textile material at different layers. So, these are the different actually evolution of the extreme cold protective clothing. Now, global applications of extreme cold protective clothing. So, at different areas globally we use extreme cold protective clothing. Emergency services are there in and military operations. So, in military operations, in high altitude military operation. So, in those cases the extreme cold protective clothing are we are need. Sports and recreation activities, we need extreme cold protective clothing. Industrial applications are there, like as we have mentioned, the cold storage and all different types of industrial applications. And you can see the global extreme cold weather clothing market, it is typically around more than $2 billion. If we see the data of 2024, so and it is gradually increasing. So, applications of extreme cold protective clothing. So, emergency service. So, in emergency service that we have in the earlier slide we have discussed emergency service. Now, let us see what are these emergency services where extreme cold protective clothing are used. So, in emergency service you can say search and rescue operation in the extreme cold condition, in case of any mishap happened in the mountain, in those cases we for search and rescue operation and for medical emergency, in those cases we need the extreme cold protective clothing. So, mountain rescue operation, suppose people are trapped in the mountain, there the rescue person needs this type of clothing. Arctic medical mission, so for any emergency situation in Arctic zone, and disaster response for any disaster happen in the extreme cold climate zone. So, there we need this type of clothing. Now, next application is military operation. So, there for military we need the extreme cold climate clothing. So, Arctic warfare or polar deployment or cold weather clothing in the extreme high altitude zone, mountaineering zone. So, in those cases situations we need the extreme cold protective clothing for military operation. So, extended cold weather clothing system, Arctic military base we need this, and special operation. So, for all this military operation we need extreme cold protective clothing. Now, next is sports and recreation. So, sports recreation we will see that there are different types of sports like in mountain or even mountaineering, there we need special protective clothing, cold protective clothing, mountaineering, skiing, polar expedition. So, all these applications we need extreme cold protective clothing. Professional climbing is one area. Antarctic expedition, so this is extremely cold condition. Winter sports, there we need extreme cold protective clothing. Next application is industrial application. So, industrial application where in the cold storage, oil and gas industry, outdoor construction. So, in where in extreme cold condition in outdoor. So, in those conditions we need this type of extreme cold protective clothing. Refrigeration workers. So, there we this type of clothing is important. Arctic oil drilling. So, in the Arctic zone, so during the oil drilling operation, there people have to be stationed there for long time in extreme cold environment. So, in those cases we need special protection for extreme cold. Utility maintenance. So, various applications are there. Now, try to understand different types of cold related injuries and their economic impacts. So, there are different types of injuries are there. You can see 700 plus annual hypothermia death in US, only in US. So, 700 more than 700 hypothermia related deaths are there, so, of which around 15% are work related. Okay. 20,000, 200,000, more than 200,000 frostbite injuries. You can see the frostbite injuries worldwide. Okay. 20% requires medical interventions immediately. So, frostbites are there, more than 200,000 cases are there worldwide. 30 to 50% reduction in manual dexterity at minus 10 degrees Celsius. So, people are incapable of doing regular performance below 10 degrees Celsius. So, that because that is a 30 to 50% reduction in manual capability. Okay. And you can see annual cost 3.2 billion US dollar, okay, annual cost of cold related workplace injuries. So, huge economic impacts are there. This is basically happen, this is mainly the problem with the cold countries. Now, let us try to understand the human thermoregulation mechanism, particularly in cold condition related zone, cold environment related situation. So, core body temperature, it should remain 37 plus minus 1 degree Celsius. Okay. Core, we should maintain our body core temperature within that zone, and the temperature sensors are there. So, there are different types of thermoreceptors in our body which sense the temperature. These are actually positioned in the brain, spinal cord, deep organ, and in the skin. Is that this brain, spinal cord and deep organs, the monitor the temperature, okay, core temperature. So, these are the monitoring the core temperature, these are central thermoreceptors, and there are peripheral thermoreceptors which receives the temperature, detects the temperature of the environment. So, which are present in the surface like skin and mucous membranes. In those places the thermoreceptors are there which detects the temperature. Now, the thing is that the what we have to maintain, whatever heat we are losing, that should be actually equal to heat production. We should, whatever heat we are producing, we should that should be equal to heat loss and heat storage. So, if we do not, if we use the heat storage, if we do not want to store the heat, so it is 0, then heat production equal to heat loss, but in extreme cold condition we would like to store certain heat, so that our body core temperature does not drop. So, that is why the equation is heat production equal to heat loss plus heat storage. So, heat production mechanism mainly if we know the thermoregulation mechanism of human body, it is a metabolic heat. So, basal metabolic rate 60 to 70% of the heat production we generate from the basal metabolic heat, and then physical activities, if we do the physical activity in the extreme cold condition. So, 15 to 30% of the total heat is produced by physical activity, and then if the body core temperature drops, then we will start shivering, which increase the heat production. Then non-shivering thermoregulation, okay, different types of tissue activities are there. Now, in the extreme cold condition, the physiological responses, as I mentioned, vasoconstriction. Vasoconstriction is the actual situation which triggers the sympathetic nervous system activation and which reduce the blood flow to the extremities by 90%. So, it from the heart the blood flows is reduced, and then it maintains the core temperature, conserve the core body heat. That is the purpose of the vasoconstriction. Now, we can see here, here is the vasoconstriction where the diameter of the blood vessel has reduced. In this happens in the extreme cold condition, in the cold in winter condition, and in summer the opposite thing happens. Here it vasodilation, which actually the blood flow increases and which enhance the heat loss. And in case of winter, in cold condition vasoconstriction is there, the heat loss is reduced by reduction of the blood flow. This is the vasoconstriction condition. And the physical mechanism, physical response to the cold exposure, shivering. So, shivering, onset of shivering is actually when core temperature drops by 0.5 to 1 degree Celsius. That body core temperature is typically 37 degree Celsius. So, at 36.5 or 36 to 36.5 degree Celsius, the shivering starts. The mechanism is that muscle contraction starts, and which actually generates energy, can increase the heat production rate by 2 to 5 times. Additional heat is produced, and here basically it demands high metabolic demand. So, that is the shivering phenomena. This is and heat loss mechanism. So, now how the heat is getting lost from the human body. So, conduction, through conduction the lower amount of heat gets transmitted from the human body. So, heat transfer through typically it is a 10 to 15%, heat transfer through direct contact, or and it should through the material it should contact, and if it is the material, if it is wet, that means water is penetrating. So, that the heat conduction rate is much higher. So, in case of dry fabric with the pores where air entrapment is there, that will prevent the heat loss due to conduction. And if it is in case of wet, that means when the water is taking the space of the air, so the conductive heat loss will be much faster. Okay. So, that is why in case of the winter dress we create additional air pockets. So, that to have the higher conductive to reduce the conduction, higher conductive insulation. So, material conductivity is we should use the material which is lower thermal conductivity, and contact area, if we can have lower contact area. So, that direct conductive heat loss is reduced, and temperature gradient. So, in case of very low temperature, so it is a proportion to the actual temperature gradient. Then convective heat loss, it depends on the air or any fluid flow, it again 15 to 20% depending on the air and fluid movement. Wind effect can double the heat loss, and convective heat loss may be much lower than this also in case of the still air. So, air velocity is main factor, and temperature difference and surface area is also other factors. Now, radiative heat loss is maximum. So, it is more than 50% is radiative heat loss. It is due to electromagnetic heat transfer, and basically it transfers through the wave. It does not need any material, any medium, but the radiative heat loss can be prevented by number of layers if we increase that, so that the wave may get reflected from that surface. The reflective coating can be used also to prevent the radiative heat loss. Major heat loss pathway, and the factor surface temperature, emissivity of the surface and surface area. This is the radiative heat loss. Then another way which is depends on the evaporation. So, evaporative heat loss is 20 to 25%, and when the moisture gets evaporated, it takes away the latent heat, and that heat is called evaporative heat loss. So, respiratory tract of the skin. So, that from skin also you get evaporated. So, from skin typically a person, if it is sitting idle, typically around 60 milliliter per day the moisture gets evaporated. When it is in insensible situation, perspiration and increase with the respiratory rate. So, a normal adult at rest, it generates a heat of typically 80 to 100 watt. So, one person when he is sitting idle and when is in cold exposure. So, it is a normal temperature, say typically around the maybe temperature around 22 23 degrees Celsius he is sitting. So, around 80 to 100 watt he will release the generate the metabolic heat, but in the cold stress the body will actually generate more metabolic heat. So, around 30 to 300 to 400 heat loss due to exposure. So, that is metabolic heat will be there 80 to 100, but heat loss is 300 to 400. So, that imbalance, so that this heat loss has to be restricted by the cold weather clothing. So, these are the different types of heat loss mechanism. Radiation, conduction, convection, they are the main mechanisms of radiative heat loss, heat loss from the human body. Now, in hypothermia situation, physiological situation and what are the risks. So, hypothermia situation, body core temperature, it's when it is less than 35 degrees Celsius, as has been mentioned earlier also earlier. So, there the hypothermia situation is there, and first stage of hypothermia is the shivering. So, through shivering body physiology, it starts generating its own heat and to maintain, to increase the body core temperature. And chattering of three teeth. So, by this chattering vibration, so we the body tries to generate more heat. Fatigueness starts, pale dry skin, it for after long time exposure, that at body core temperature, that the skin becomes pale and dry, maybe due to the this hypothermia effect, disorientation and slow reaction time. So, that temperature, at that temperature, that then we can tell the hypothermia started. In case of mild hypothermia, so first stage of hypothermia, then if the body core temperature is dropped below 35 degrees Celsius, that is 32 to 35 degrees Celsius, the symptom is that shivering and impaired judgment, clamminess and apathy, that these are the symptoms of hypothermia, and compensatory mechanism still functioning. So, these are the different shivering and all chattering of teeth. So, these compensatory mechanisms are still functioning at that temperature, but moderate hypothermia, when the body core temperature becomes 32 to 28 to 30 degrees Celsius, and that shivering will stop, confusion and slurred speech will be there, thermoregulation beginning to fail. So, the body thermoregulation will start failing, and severe hypothermia less than 28 degrees Celsius of body core temperature, and cardiac arrest may take place, people may get unconscious, and complete thermoregulatory fail. So, the thermoregulation system will not work if the body core temperature is below 28 degrees Celsius. In that is why our extreme cold climate clothing is very important, because people has to stay there for long time, and if continuously the heat is lost, the body core temperature will quickly reach to that severe hypothermia region. So, we should protect ourselves by proper clothing. Now, cold induced injuries and prevention, there are different types of cold induced injuries. So, you can see that the first thing is the frostbite. So, you can see this is the different stages of frostbite. So, here it is a normal frostbite. So, which is actually it is a superficial. Okay. So, superficial normal frostbite, we always there is it is there when the tissue freezing at minus 0.55 degrees Celsius. So, just below the freezing temperature. So, we can have a normal frostbite with a it is called frost nipped. Frost nip is superficial there. Then superficial frostbite is this is a frost nip, okay, and normal skin is there. And if you see here superficial frostbite, the skin deep frostbite, then deep frostbite in all layer. If you see, this is the deep frostbite, where the frostbite takes place in the all layer of the skin. So, the areas basically fingers, toes, nose, ears, which are exposed to the, which are typically exposed to the environment, extreme cold environment, where the skin get damaged. Okay. So, extreme deep frostbite, where all the layers you can see of the skin gets damaged, and it needs immediate medical attention. Next type of cold injury is the trench foot, okay, condition, non-freezing cold injury. So, trench foot typically takes place above 0 degrees freezing temperature, 0 to 15 degrees Celsius, but trench foot takes place after long exposure in wet cold exposure for long time. Suppose some person is working for long time with a cold water condition. Okay. In that this type of in winter situation where temperature is around 10 degree and people one person is working in the wet condition for long time and typically above 12 hours time. So, in that case the trench foot type of cold injuries takes place. So, blood vessel and nerve get damaged. So, in this situation, so we should protect ourselves from any wet exposure or cold exposure to prevent ourselves from the to protect ourselves from the trench foot. And chilblains is a actually inflammatory response to the cold or humidity. So, above freezing temperature, but less than say again 0 to 15 degree Celsius, the red swollen itchy skin, this is very commonly happening occurring this type of situation. So, toes, okay, fingers, heels, ears. So, in this type of all these situations places we get this type of injury, and the preventions of this type of cold injuries: appropriate layering of clothing, keep those places dry and maintain nutrition and limit exposure. So, we should limit ourselves from this exposures for in extreme cold condition to wear, if we try to wear warm gloves or maybe socks, then we can protect ourselves from chilblains. Okay. The biomechanics of in a cold environment, movement analysis, joint movement. Okay. So, joint movement cold effect 10 to 20% reduction in joint movement, okay. And muscle function, the strength loss 15 to 20% 25% decrease in cold condition, and coordination impairment, fine motor 50% impairment in skin temperature less than 15 degree Celsius, and energy cost metabolic heat increases 10 to 30% higher energy demand. That is very important here in this case. Now, cold induced cognitive changes, what are the different types of cognitive performance in cold environment. So, temperature below 15 degree Celsius, okay, it begins to affect the cognitive performance, okay, significantly. So, above say 15% we are not getting affected. So, what are this affect? The domains are the attention reduction, okay, and vigilance. So, people exposed at that temperature, so you will try to lose the attention, working memory decreases, okay, and executive function impaired the planning and decision making, okay, and processing speed, his response will slow down. So, these are the different types of cognitive responses, and performance degradation timeline, see 15 to 20 minute 5 to 10 minutes exposure, initial distraction of the focus, okay. Then 15 to 30 minutes exposure, measurable cognitive performance decline, okay. And 45 plus minute exposure, significant impairment of the complex cognitive task. So, a person has to work outside it and the extreme cold climate clothing. So, and he has to think, he has to do its all the performance properly. So, in that case we should actually protect himself from the extreme cold by proper designing the clothing. Work capacity and performance in cold. So, 15 to 20% physical work capacity reduction, 30 to 50% manual dexterity impairment, 10 to 30% increase in energy expenditure, and 20 to 40% task completion time increases. So, that these are the different types of effects in extreme cold condition, and a person has to perform normally if we can protect him from the extreme cold condition. And for that the heat balance, heat generation and heat release should be balanced. If we cannot keep the heat balance properly, if the heat release from the body is higher than heat generation, then our body core temperature will reduce gradually. This is the extreme heat condition, cold condition heat balance. So, M is the metabolic heat generation and work done is W. So, represent metabolic heat, internal energy production, external work done, and C is the convective heat loss. Okay. And in case of wind condition, this convective heat loss is very high. Ck is the conductive heat loss, C res is the respiratory heat loss, R is the radiative heat loss, okay, and responsible heat loss respiration, radiative heat loss, and E as a evaporative heat loss, evaporative through respiration, evaporative heat loss through respiration, and E is the heat loss through the skin. So, evaporative heat loss through the skin, E. So, we should there has to be balance. If the right hand side matter is higher, that means you are losing the heat from the body. So, that in that case, so we have to restrict the, we have to reduce the radiative heat loss, we have to reduce the convective heat loss, we have to reduce the conductive heat loss. So, all this, see, we have to balance this metabolic heat loss and work done. That is the if we consider this is a constant amount, or in that case. So, and if this are increased in this case, that is conductive heat loss, radiative heat loss and convective heat loss. So, if this radiative heat loss, conductive heat loss, if this increases, so in that case the heat balance will not be there, body heat will, body temperature will drop drastically. So, to reduce this we have to design our clothing properly, because even evaporative heat loss from skin, that can be restricted by proper designing of clothing. Okay. So, these are the we have this are the different mechanism, and we have to balance this equation, and this different types of heat modes, heat transfer modes in cold weather clothing, that we have discussed: conduction, convection, radiation. This we will discuss in the next class. Next session we will start with the heat conduction. Till then, thank you.